and we're going to talk about triangles. This whole entire chapter, I believe, yep, is about triangles. All right, different types of triangles, and that's what we're really going to talk about today, are the different types of triangles. Over here on the side, I actually have a bunch of different triangles. So let's pick this triangle right here. Copy and paste it, put it right here, and if I could grab it, there we go. So we're going to talk about several different types of triangles. What we're going to do is, this lesson is called classifying triangles. We're going to name them. That's what classifying means, okay? So we're going to classifying, did I spell that right? Yep. Classifying triangles. But we're going to classify them two different ways. All right, one way, we're going to classify them by their angles. We're going to look at see what angles are inside the triangles, and then we are going to name the triangle by what types of angles are in the triangle. So that's one way we're going to classify the triangles. You're going to have questions on the quiz and the test. They're going to give you a triangle. They're going to say classify the triangle by its angles and by its sides. Did you hear what I said right there? You're going to have a question. I promise you, you're going to have a question on a quiz and a test. It's going to say classify the triangles by its angles and by its sides. So how many answers would you have on that question? You would have two. One, it's named by the angles, and the second one, the second part of your answer, is named by the sides. Get your head up, please. You should be taking notes. You should have a pencil in your hand. You should be taking notes. Okay? So we're going to classify triangles, okay, by two different ways, angles and sides. So here's our first triangle. We're going to take a look. Now, we've already learned about these angles, the words for these angles. So look at this angle here, and this one here in this triangle. What type of angle is this one, and this one? They're all acute, aren't they? Every single one of them in this triangle are acute angles. So we have three acute angles. Would you agree? So you don't have to be a rocket scientist to figure this out. Okay, so what kind of triangle do you think we're going to classify this or name this if there's three acute angles? We'll call this a what? An acute triangle, okay? It's an acute triangle. That's a symbol for triangle. I think I've shown you that before, haven't I? Yeah. So acute triangle. Why is it an acute triangle? Is it just because there's one acute angle or two? No, there's how many? Three. All three of them, okay? All three of them have to be acute to be an acute triangle. Everybody got that? So if you had a question like this and it said classify the triangle by its angles, you would say what? It's an acute triangle. Pretty simple, isn't it? Okay, let's move on. Let's do another type of triangle. Look at this triangle. It's kind of little right now. Let's make it a little bit bigger so we can see it. Now look at this triangle. If we want to classify it, now right now we're just looking at triangles and we're going to classify them by their angles. We'll talk about the sides after we finish up all the angle ones, okay? So right now we're just classifying the triangles by their angles. So look at this triangle right here. Okay, this triangle right here. What kind of angle is this one right here? That's this one right here. That's acute. What about this angle up here? That's acute. So is that an acute triangle because there's two acute angles? No, there has to be how many to be an acute triangle? It's got to be three. Look at this big old angle right here. What kind of angle is that angle? It's obtuse. It's an obtuse angle because it's what? It's bigger than 90. It's greater than 90 degrees, so that's an obtuse angle. So if you have a triangle with just one obtuse, not three, not two, but how many? One obtuse angle. If we have one obtuse angle, what are we going to call that triangle? We'll call it an obtuse triangle. Now let's think a little bit. Didn't we learn about how many degrees inside of, have we learned about that before? I don't know if I've officially taught it in here or not. I don't think we've officially taught it in here, but we'll teach it pretty soon here. And I don't think they teach it yet. But anyway, this you know this already. Right, there's 180 degrees in a triangle. You probably learned that back in not elementary, might be 7, 6, something like that grade. All right, that there's 180 degrees in a triangle. So if you have one obtuse angle, that's going to be more than 90, right? Could you have another obtuse angle inside of a triangle? Could you have two obtuse angles in a triangle? Wouldn't be a triangle because why? Because if I had two of them, right, if you look at this, watch. If it's more than 90, it's obtuse, okay? So there's an obtuse. Can I have another obtuse angle in here? No, because look, if I make this obtuse, then is there any way for them to connect to be a triangle? No, I'd have to connect here, and then it wouldn't be a triangle, would it? All right? So there's no way that I could have two obtuse angles. Let's think about the math of it, though. An obtuse angle is more than 90. If I had another obtuse angle, I'd have two angles that were both more than 90. So can I have two angles that are both more than 90? Because those two angles would be more than 180. What about my third angle? My third angle can't be like negative degrees, can it? No. So you can't have two obtuse angles. So that's why there's only one obtuse angle in an obtuse triangle. Does that make sense? All right. Let's do another one. Let me find my triangle. It's up here somewhere. There it is. And you probably know this one already. Yeah, very good. Okay, so we had an obtuse triangle. We had an acute triangle to begin with. And then, oops, there we go. Then we're going to have a triangle that looks like this. We'll scooch it in like that. Now, it doesn't say, but if I put this little mark right there, what's true about this triangle? It's a right triangle, okay? So if it has, what? One right angle, and we'll just call it a right angle. Okay, if you have one right angle, then what do we call this triangle? We call this a right triangle. Again, can you have two right angles in a right triangle? That's right, because watch. Well, not necessarily a square, but you couldn't have a triangle, because watch. If I wanted to make a right angle here, is there any way I could keep on going and make that a triangle? There's no way in the world, is there? Okay, what would that other angle have to be, though? It would have to be what? It'd have to be acute. So look at a right triangle. Same thing with an obtuse triangle. A right triangle has one right angle. What do the other two have to be? They have to be acute. What about an obtuse? I got one obtuse angle. What do the other two have to be? They have to be acute. Can you have one obtuse and one right angle in a triangle? No. Again, it's impossible because those two angles would be more than 90, right? And you can't have a triangle with two angles being more than 90 because three of them have to add up to 180. Does that make any sense? All right, that's pretty easy. Okay, that's classifying by its what? Angles. Now we're going to talk about some triangles. We're going to classify them by their sides. Okay? Yeah, isosceles is one of them, but we're going to actually, I've got them all out here. Let's do this one. Let's see which one do they do first. Yeah, let's do this one. Yep. Yeah, you guys heard this before, haven't you? Either that or you looked in the book at what we're doing. But you probably learned this before. I don't think it's anything new. There we go. Now look at this. Now you're going to have to trust me on this, but I'll put the marks to show you. Yeah. And let's go different color. I'm tired of... Watch this. If I put a little tick mark here and a little tick mark here and a tick mark here, what's true about those three sides? They're all equal to each other, okay? So we've already learned that. So we know what the little tick marks mean. So if I do this, that says that this side, and if you want to name them, okay, this is an equilateral triangle, okay? It's an equilateral triangle. Let's write that down. And what does it mean to be equilateral? Equilateral. Because we talked about this before, the word lateral means sides, okay? And the equa means equal sides. So all three sides are equal to each other, okay? So if all three sides are equal to each other, then it's an equilateral triangle. It makes sense, doesn't it? Okay. What if... let's see. Do I have one already drawn? Let me see if I already have one drawn. Not really, but whoops. I'll draw one. So that's three sides equal, right? All, if you want to put three, you don't have to put the three because if it's a triangle, it has three sides, right? But all three sides are equal on an equilateral triangle. Let's do this. Let's copy this, drop it down a little bit, paste it, and I'm going to scooch this in a little bit. What? Oh, sorry. Let's go like this. All right. Now, if you notice what I did, I just took a corner, I scooted it in. So, let's mark this again. So this side and this side are equal. Does this side look equal to these two? No. And I made it pretty obvious, didn't I? Okay, I made it pretty obvious. Now, if I have a triangle with only two sides equal to each other, it's not equilateral because equilateral means all three sides are equal. But if two sides are equal, what is it, Zeke? You said it earlier. Isosceles. Now, this is a big problem with spelling, so let's spell it correctly. Now, I'm not going to mark it wrong if you don't spell it right, but I just got to think about spelling. So, ISOS, okay, that's how we started off. Isos. And then Celes, C-E-L-E-S. You ever see Celine Dion spell her name? Celine, C-E-L, right? It's like this. It's C-E-L-E-S. She sang that song about the boat that crashed or whatever. The Titanic. The Titanic song. You ever hear that? Is that what it's called? Sorry. I'm not a big fan of Celine Dion. So, but anyway, she spells her name C-E-L, and it sounds like an S though, doesn't it? Celine. So, Isos, what? Celes. C-E-L-E-S. Isos, Celes. Write it down. Spell it right. Okay? It's really nice if you would spell things correctly. So it's called an isosceles triangle. Isosceles triangle has what? Two equal sides. Technically, here's the definition. Watch this. I'm not going to be super picky about this, but I just want you to see this. At least two equal sides. Now, what does that mean when I say at least two equal sides? What about this one? Does that have at least two equal sides? Yeah. So I could call this what? I could call this isosceles as well, couldn't I? All right, so let's put an or. Let's put an or right there. So I could call this isosceles because technically the definition of isosceles triangle is at least... Now, you don't have to put them both, but you could, I'm showing you, you could say this is equilateral or you could say it's isosceles. But on this one right here, you only have one choice. The only choice you have on this is that it's what? Come on, it's right there. It's isosceles. That's right. Okay, you only have one choice. So if the two sides are equal, then it's isosceles. Now, usually, if it's equilateral, I would rarely ever call that isosceles. Okay, if all three sides are equal, I'd probably call it equilateral. If only two sides are equal, I'd call it isosceles. But for some reason, the definition of isosceles means at least two of the sides are equal. All right, it's not that big of a deal. Don't get all confused about that part of it. All right, let's do another one. I'll just make up my own, and we'll make it white like the other ones. Okay, so watch. Let's do this. Like this, like that, and like that. Now, it looks obtuse, but that's classifying it by its angles. We want to classify it by its sides. So if you look at this, watch, let's mark it like we did the other ones. So I'll give that 1 tick mark, I'll give this 2, and I'll give this 3. Do any of them have the same number of tick marks? Well, it must be true about all three of these sides then, if I marked it like this. All three are different sides, different lengths, right? Okay, so how many are equal? No sides are equal. So no sides are equal, and we call this a scalene triangle. All right, scalene. I don't know where they get that word from, but it just means that none of the sides are equal. So if you get a triangle with none of the sides equal, we call that a scalene triangle. All right, not that big of a deal. There's not a whole lot we can do with that. With isosceles, there is. Okay, there's a lot of stuff we can talk about with isosceles triangles, and we'll do that at some other point. Equilateral, there's also, and I'm going to show you one more thing about equilateral. Equilateral, there's stuff that we can do with equilateral triangles. All right, but with scalene, not so much. All we have to do is just recognize that if none of the sides are equal, we call that a scalene triangle. Make sense? Okay, very good. Let's do a couple examples, and you can see where we're going to use. Actually, this might be going ahead a little bit. Do you mind? If we just, I think this might be covered somewhere else. So I'm not positive, but let me hit it anyway, just in case it's not. Let's go back to this equilateral triangle. Let's take a look at it. If you have an equilateral triangle, just looking at it, I don't have a online protractor or anything, but if I did, if all three of these sides are equal to each other, look at this angle, and look at this angle, and look at this angle up here, A, B, and C. What does it look like might be true about all three of those angles? They are. They're absolutely equal to each other, okay? So, if you have an equilateral triangle, guess what it also is? It's also, instead of equilateral, we could also call it what? What do you think? Let's make up a name. Well, they're all the same, and they're angles, right? This means equal sides. This means equal sides. What would mean equal angles? Equiangular. Equiangular, okay? So, if all three angles are equal, we could also call that an equiangular. Now, that would be classifying it how, though?
If it's angles.
By its angles,
Is that
okay?
a real word?
It is a real word, okay? Equiangular. Absolutely, it's a real word. All right, so anytime you have a triangle that has all three sides equal to each other, automatically all three angles are going to be equal to each other. It doesn't matter how big or small the triangle is, okay? As long as all three sides are equal, not just two of them, but all three. If all three sides are equal, all three angles are equal. Now let's do this. Let's think about this a second. We already said that if you add up all these angles, they added up to what? 180, right? So what if every angle in this triangle is exactly the same? How could you find each one of these individual angles? By 3, right. 180 divided by 3. Everybody see that? Because if I had $180 and I brought 3 of you up here and said, okay, I'm going to give you $180, but I'm going to split it up evenly between the 3 of you, then what would you do? It's $60 a piece, right? Well, it's the same thing. If I have 180 degrees and each angle is the same, right? If I split that 180 degrees evenly 3 ways, what is the each angle going to be? It's going to be what? 60 degrees. Everybody see that? And that doesn't matter. It doesn't matter how big the angle is, or sorry, triangle. It doesn't matter how big the triangle is or how small the triangle is. Anytime you have an equilateral triangle, it's also going to be equiangular. And if it's equiangular, every angle in there is 60 degrees. I heard somebody else say when we did this equilateral that they would be 45. They wouldn't be 45, would they? Because 45, 45, and 45 doesn't add up to 180. But 60, 60, and 60 does add up to 180. Is that making sense? All right, let's do an example. Let's scooch all the way down to the bottom here. And let me find a good one here. All right, let me draw this one out. Let's make this white again. What? Of course. I didn't give you homework last night. Let's make it about like that. Okay. Alright, and I'm going to put some numbers in. Actually, they mark some sides equal. Let's do that first. They say that... Oh, I didn't really draw that right. Let's try this again. Yeah, it's a little bit better. Alright, now let's make that a different color. And watch what they do. They say that this side and this are equal to each other. Everybody see that? And they label it, so let's label it. That's KM. This is an L, and that's a J. And they also tell you that this side right here, KJ, is 0.75. Don't know why it's 0.75, but that's what it is. And this one up top is 1.3. And they also do this. Watch. They put a little line here, a line here. And so that whole entire thing from there to there is 1.5. Okay? And what are they asking you to do? They don't ask you to do anything. They just... oh, they say M is the midpoint too. Alright? So M is the midpoint. So they say, classify triangle JKM. Let's find JKM. So here's J, here's K, here's M. So we're talking about this triangle here on the left. It says classify it according to its sides. So equilateral, isosceles, or scalene. So let's take a look. Well, this is 0.75, and this thing has one tick mark on it, right? Any idea what this would be? Remember, it says M is the what? The midpoint, isn't it, of this thing right here. So if this has one tick mark, what do you think this is going to have? One tick mark. So if the whole thing is 1.5, how do we find LM? We divide it by 2. Everybody seeing that? All right, that's the stuff you have to look at and understand. So if the whole thing is 1.5, we divide that. So that's 1.5. What's half of 1.5? 3/4, isn't it? Which is 0.75, right? So this is also 0.75, and this is also 0.75. Now they're asking for JKM. So watch. This tick mark, this has one tick mark. It's 0.75. So what do you think KM is equal to? It's got to be 0.75 as well. Everybody seeing that? Okay, you got to go by the information they give you. So look, I got a triangle with all three sides equal to each other. So what would I call? How would I classify triangle JKM? I would call it equilateral. Exactly right, because all three of these would be equal, right? They didn't put a tick mark there, but I can, right? Because I figured out this was 0.75, all right? And so is this, so is this, so is this. Does that make sense? So this triangle right here, that big old triangle, that right there is equilateral. Now, if you wanted to, you could also say it's what? You could say it's equiangular, right? Because if it's equilateral, but if we want to classify it by its sides, what's another way that I could name it if we classify it by its side? I could say it's isosceles, right? Because it's got two sides equal. Remember, 2 or 3 sides, you could call it isosceles. Okay? If there's only 2 sides, you call it isosceles. If there's 3 sides, you could call it equilateral as well. Got it? That's pretty easy. Let's do one more, okay? What time do we get out of here? In a minute. Alright, well, we can do this real quick. I got a worksheet for you, so don't leave the room without the worksheet. Let me just do this real quick. I might not do the whole thing exactly for you, but it'll get you started. Watch. This is given equal to each other. This one is 9x minus 1. This one is 4x plus 1. And this one is 5x minus a half. 0.5. Alright, here we go. It says, find the measures of the sides of this triangle. So they want you to find the measures of all 3 sides. What would you do here? Real quick, what would you do? You go 4x plus 1, what? Equals 5x minus 0.5. You'd solve for x, plug them in, and then you can find the lengths of those sides. Let me give you a worksheet before you go.